Hi lads, this video is going to go through question 4 of sample paper A. So first of all, we can see this question is going to be involving the camera. So shown below is a 3D model of a camera. Also shown is a drawing of the LCD panel on the top surface of the camera, which displays information such as battery level, photo histogram and other camera related settings. So just relating to this here. Part A then relating to the camera, it tells the outline drawing of the battery level display is shown below. Shade the display to show the battery level displaying at 40%. So if we count them out, we have 10, 20, 30, 40, 50, 60, 70, 80, 90, up to 100%. It's 5 to 10 equally spaced distances. So we need to shade the first 4. So to make sure, what you can do is always label them out here like that, so you know where to stop for each one. So there's our 4th box here, and we're going to stop at that point. So nice and simple for part A. Part B then tells us an incomplete drawing of the photo histogram display is shown below. Complete the drawing by constructing an axial symmetry in the line LL. So we know from transformation geometry, axial symmetry is basically a mirror image. So taking this and flipping it over the other way. So with this here, we're going to take all of our lines across, perpendicular to our axis given. So you can see the axis is a vertical line, so we take all of our heights here horizontally across. And then we take each distance, which is unique, and step it across as well. So for example, that distance there, that steps across to there. Our next distance is that one there, steps out to there. Our distance here steps across to there. And our last distance is that distance there, and that goes across. All it's a matter of doing is taking them all joined together. And then that completes part B. Part C then, it tells you the camera company wish to place a triangular button ABC on the back of the camera. The XY line, which is given to us here, is the perimeter length of triangle ABC. So basically, if I was to draw like a triangle there, the perimeter is basically the length from here all the way around back to the end again. And it has sides in the ratio of 3:4:5. Draw the triangular button. So we know what the ratios, what we always do first is take them and add them together. So we have 3 + 4 is 7, plus 5 is 12. So what we want to do is divide this XY line into 12 equal parts, so that one side is in the ratio of 3 equally spaced distances, the second side is in a ratio of 4 equally spaced distances, and the last side is going to be equal to 5 equally spaced distances. So to divide a line, first of all take a line at a random angle. We're going to step out 12 equally spaced distances. So for example, I could go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110 and 120. Or you could take a random distance on your compass and step that out equal distances. Next thing to do is join the 12th one to the end of the line. So there's my 12th one there, join that to the end of Y, and then use slide and set squares take the rest of them up. And what we've done is we've moved a line, this one here, that already has 12 equally spaced distances, and we've moved it up to make it the equivalent of the XY line. So now we basically divide that line into 12 equally spaced parts. So, like I've said to you before, anything involving triangles and ratios, always take the middle one, which is 4, and make that the base. So if I rewrite it out here, that's going to be the base of our triangle. That's going to be one side, and that's going to be the other side. So first of all, I'll count in 3 distances. 1, 2, 3. That's going to be one corner on my base. I have 1, 2, 3, 4. That's going to be my other corner. And I have 1, 2, 3, 4, 5 left that I can take for the other side then. So taking my side, that's a ratio of 3. Rotate that around, just like that. Then go to the opposite end. Take the distance of 5 and rotate it around to hit the 3. And when I join those together, they'll give me a triangle that's in the ratio of 3 is to 4 is to 5. So 3, 4, and 5 there. So the next part is part D. And part D tells us a navigation button is also to be added to the back of the camera. And this will be based on a regular octagon with a base length of the line PQ below. Draw the navigation button. So it's based on an octagon. I think we know about octagons. They have 8 sides. And then for all those sides, we need to divide that into 360 degrees to give us our angles. At 45 degrees there. So that's how we work out our base angles. We already have the length PQ, so we can use that for the length of each of our sides, and hopefully be able to see this. I might just open the blinds with the electricity after going there. So just in case electricity goes off and on again, I just have the blind open behind me. So 45 degrees, once again, we got that because there's 8 sides in an octagon. An octagon can fit inside a circle. Circles made at 360 degrees, so 360 divided by 8, and that gives us our 45 degrees, and we already have the length of our side, PQ. So 45 degrees, out from P, out from Q. Take that distance and swing it there and there. We take our sides straight up, keeping that distance. We can now mark it off there and there. Then we go back in at 45 degrees, marking it there and there, and then we have our last side as a result then, and that gives us our octagon. And what I'll do is just go over it heavy then afterwards. So that completes part D. Last part we have for this question is on the next page. So you can see part E is based on the camera once again. This time we're looking at drawing an elevation in the direction of ROA, a plan projected from the elevation, and then determine the true shape of the surface S. So that surface there. So the first thing we need to draw is our XY line. Now to determine the height, we take the total height and then we make sure that we don't have it any higher, for example, drawing our XY line way up here. Because otherwise the question is going to go off the page. So we can see it's not too tall. So what we can do is put the XY line maybe somewhere around here in the center of the page. And to make sure I don't go off the page out this way, I can mark the bottom corner maybe somewhere around here. So I know I have plenty of room then, that when I measure across, measure up, that I'm not going to go off the page. And that I still have loads of space underneath to fit in my plan as well when I put a gap in between the two. So, as always, draw boxes to fit in your object. So first of all, I'm going to draw a box to fit the elevation in, and I can see it's going to be 130 out to there, and then I have 15, 20 and 15. So I'll go 130 first, then I'll go my 15, 20 and 15 like that. So there's my widest points I'm going to have. There and there. In terms of the height, I'm going to have a height of 80 up to where the quarter circle is. And then I can see that there's going to be a radius 40 after that as well. So I can add our 40 onto that. And then there's going to be a small button that's going to be sticking out a further 5mm. So I can add that 5mm there too. You can see there now, I have loads of room to fit my elevation in that box there. And then we know that our widths are never going to change, so I can take those there. Maybe put about 15, 20mm gap in between the two views. And for my plan, I'm looking at my depth going this way. So I can see that it's 50 out to that point there. And then what I have then is I have the base of an octagon. So I'm going to have to just use the information given here to get that base sticking out that little bit further. So I can see there though, I will have plenty of room underneath. I'll just move that down. There's going to be plenty of room there to fit it inside. So starting off with the elevation. I'm going to draw the main outline of the camera first, and then I'm going to put in all the details, like for example the lens, that little part there, and the button. So the main outline of the camera, I can see that it's going to be heavy for the base all the way along. It's going to go up heavy on the right hand side up to that 18mm point. So I just mark that off there. And then I have a radius 40 then. So I already have my 40 height marked up there already. I need to measure in 40 here. And that's going to be the center of where my quarter circle is going to go. And that quarter circle is going to stop at that point there as well. So there's my quarter circle, and then I can see that from here it's going to be heavy all the way across where this bit juts out, all the way to the end. That in turn can be taken down heavy all the way on the side there. In terms of the lens, you can see there it's up 60. And then we take a line across to get our center. And you can see our center is going to be across 65. You can see there it's lining up with it. So I'm going to go up 60. I'm going to take a line across. And I'm going to measure in 65mm. And that's where the center of my camera lens is going to go. My two radiuses are going to be a radius 25 for the inner and a radius of 35 for the outer. So I'm going to take a radius of 35 first. Make sure you draw that nice and heavy. And then we have a radius of 25 then. After that then, what I can do is I can mark out the position of the button, or can I? No, I'll need to take my plan view to get that in line, because I can see the front edge there. Actually I can go in 15 and then 20. There's my 15, there's my 20, so you can see there, in line with that 20, it goes up, and that gives me this side of the button here. So that 20mm mark. You can see the measurements are very, very close together here. It could be hard to see in some parts. But you can see there that line, it goes up there, over and across. And the button is a radius of 10. So if I double that over, I get a diameter of 20. So there's my button drawn in now. And I can see for the screen then, that's 60mm distance going across there. If I follow that line down and across, I can then get this side of the little display thing here, or if it's a flash. And then I have my measurements here going down 5, down 15, and it's a width of 30. So it's 60 from the very end. So I measure 60 out there. Take a light line down. I have to go down 5 and then 15, and then the width of this here is a total of 30. Then to complete this octagonal front, it's my 15, 20 and 15 lines. So there's my 15, there and there to there. There's my 20. And then my 15 left over there then as a result. And that then completes the elevation. So I have nothing else I can put in there. Now that I have all these widths, I can use them now to solve my plan. So what I'll do is, I'll get the outline drawn here, and then I'll take down my camera lens end that's sticking out. So I can see the back line is going to go heavy all the way across to the end. And the thickness of that part there, you can see, is 35. This part here is 50, so you don't confuse that thinking it's the whole width 50. That bit there is 35 sticking out, so I'm gonna have two different distances. So there's my 35 first. Just take that back lightly for now. And then I'll mark off my 50 then. There. So my 35 goes down to there, and that's going to go across all the way to my 15, 20, 15 point. So that line there. So I'll take that down lightly first. I can take that across there. And then I can see it's going to jut out and then go around there, back and across again. So the distance there I have, that's the 5mm. So what I need to do is, I need to take my 50mm distance and go at an angle of 45 degrees. So I need to take this line out here first, out to my 50. Take these two lines down here, go out at 45 degrees there, take it across, go back in 45 degrees there, and then close it up the rest of the way. So it's based on a partial octagon. So you can see from the question here, they're on involving drawing an octagon. It's used again in this part here, knowing their angles are 45 degrees. And while I'm here now, I may as well just show that that is surface S there. And that there is surface S as well. Just move that down so you can see it. Next thing I can do is draw the button in plan. So for the button, it's a raise of 10. So I need to get the center point there. Take that down lightly. And the center line is in line with that 35 there. So when I extend that 35 across, where it hits there, gives me the center of my button in plan. So there's my button drawn in plan. And I'll draw this display screen now. So the display screen is 60 and then 70. So I measure across my 60mm distance first. Then it goes a further 70 to there. And then it's 5 and then 25. So 5 and 25 gives me the 30 there. And that can then be drawn in heavy there. So the last part then for the camera is the lens sticking out. So what I need to do is take my two widest distances there. I can see there it's 20 that sticks out further. There's my 20mm there. And I can take that heavy there and there. And I'm also going to have my inner lens, and that goes, you can see, all the way back to hit off the back of the camera. So these distances here, they're taken as hidden detail. They are there, we just can't see them in our plan, so we mark them off as hidden detail. And that completes our plan. So far we've completed part 1 and part 2. The last part involves that surface S. And it's telling us to determine the true shape of it. So, in order to see the true shape of it, we have to look in perpendicular to it, for example. So if we're looking straight in here, we can't see the true length of that because it's at an angle. But we know from our previous questions involving rotations, we could take that as a hinge point and rotate that surface S so that's level. Because we know that when we see a line that's parallel to the XY line in plan, it's going to be a true length in elevation. So if I get my compass, take that as my hinge point, I can rotate that back until it's level, like that there. There's where it has level point. And we know that that's a true length. That's now a true length. We know in elevation, heights never change. And we can take that straight up. And what we can do then is, we can draw a heavy line there. We can say TS for true shape of surface S. What you can do as well, colours in the exam, you could very clearly show that that's your distance there, that's your surface S there, and then apply a bit of colour here to show that that's your true shape there as a result. So you can see the difference between the two and finish this. See how skinny that width there is? So you know it's not the true shape because it's at an angle. And then we can see then there we have the true shape. We can see how much wider it is compared to it. So that completes question 4.